Welcome to aminacademy.com. In mathematical economics, regarding exponential and logarithmic functions, we'll discuss. Here, this is a graph of logarithm and exponential functions. Y equal to 2 power x, and it becomes logarithmic, means y equal to log of base 2 power x. Now, exponential and logarithmic function. Exponential functions are crucial in mathematical economics for modeling growth and decay pattern in various economic phenomena. They are particularly useful for describing situations where the quantity increases or decreases at the rate proportional to its current size, such as compound interest, population growth, and the spread of information or diseases. Now, what is exponential functions? Look at here. This is an exponential function graph of f of x equal to 2 power x. Exponential function is, its name suggests, involves exponents, that is power. But note that an exponential function has a constant as its base and a variable as its exponents. This variable is x is a power and 2 is the base. But not in the other way around. If a function has a variable as the base and a constant as the exponent, then it is a power function, but not an exponential function. Exponential function must be, the power should be variable. An exponential function can be in the following forms. Here, in mathematics, an exponential function is a function of form f of x equal to a power x, where x is a variable and a is the constant, which is called the base of the function, and it should be greater than 0. Now, what is logarithmic function? If the basic logarithmic function of the form f of x equal to log x base a, or y equal to log x base a, where a is greater than 0. It is inverse of the exponential function a power y equal to x. Now, look at here, f of x equal to log of ln x minus 2, g of x equal to log 2 into x plus 5 minus 2, h of x equal to 2 log x. These are the some examples of logarithmic functions. Natural exponential and logarithmic functions. Look at this. Y equal to e power x is a natural exponential function. If you convert this as y equal to ln x, it gives a logarithmic function. That is, ln is natural logarithmic function. It is a power function. Y equal to e power x. Exponential function, here this is logarithmic function. Natural exponential and logarithmic functions are mathematical functions that are inverse of each other. These are inverse of each other. Natural exponential functions, the functions y equal to e power x, where e is the transcendental number, that is 2.71828, it's continuous, is a transcendental number. Natural logarithmic function, the function y equal to ln x, which is the logarithmic function with base e, natural logarithm. Here are some other things to know about exponential and logarithmic functions. Inverse function. Logarithmic functions are the inverse of the exponential function and vice versa. Graph. The graph of exponential and logarithmic functions are the reflections of each other across the line y equal to x. This is a baseline y equal to x. Domain and range. The domain of a logarithmic function is a real number, numbers greater than 0, and its range is all real values. Natural logarithm is in calculus. Natural logarithms are used frequently in calculus. Continuous compound interest. The continuous compound interest formula uses natural logarithms. Logarithmic transformation of nonlinear function. Suppose nonlinear function is given. That means here dots, little widespread. We have to connect with equivalent Logarithmic transformation. Logarithmic transformation is a method used to convert nonlinear equation and functions into linear ones. It's a common way to handle nonlinear relationship between variables in a regression model. So far, we discussed the notes about logarithmic functions or exponential functions useful in mathematical economics. In future videos, we will do some example problems regarding this concept. If you have done, please subscribe our YouTube channel.